Today we will be talking about standard deviation and outliers. First thing you should remember while starting this video is that you need to take Cornell notes on the video. These need to be done for class on Monday, and we will be looking at them. Failure to complete these will result in attending extended row with Mr. Braycheck and Mr. Dunn to finish your notes. Take a minute and set up your Cornell Notes page in your Math Interactive notebook. Your first main idea of this lecture is standard deviation. Standard deviation represents how spread out a set of data is from its mean or average value. Higher standard deviations mean that the data points are more spread out. Lower standard deviations mean that the data points are closer together. Sometimes you'll see positive standard deviations. This means that the data in general is higher than the expected value, or larger than the expected value. If you see a negative standard deviation, that simply means that it is smaller or lower than the expected value. For example, because standard deviation can be somewhat complicated, we want to make sure we give you concrete examples to look at. The yellow set of data here will have a low standard deviation. For example, potentially 1.15, meaning it's very closely knit and closely put together. Whereas the data in red would have a higher standard deviation because it goes from 1 all the way up to 30 instead of just 1 all the way up to 14. It would have a standard deviation potentially something like 3.5. So a higher number farther from 0 means a higher standard deviation and the data is more spread out. A lower number closer to 0, like 1.15, means the data is more packed together and closer together. A standard deviation of 0 would represent a data set that has no standard deviation and all hits the expected value. The second main idea of this video is outliers. Outliers are numbers which are either much larger or much smaller than the rest of the data. For example, in the data set below, it's easy to see that 5 is much smaller than the rest of the data, and 99 is much bigger than the rest of the data. So both of those numbers, 5 and 99, would be considered outliers in this case. Outliers are generally pretty easy to spot. They are numbers that stick out to you when observing a set of data. We want you to practice this. For class on Monday, you need to answer the following questions in the summary section of your Cornell notes. The first question is that you need to rank the following data sets in order from lowest to highest standard deviation, meaning that you're going to rank them from the data set that is the most tightly knit to the one that's the most spread out. The second question asks you to identify any outliers. So you're going to look through the data and identify which points are either far bigger than the data set or far smaller than the data set. That's all you've got to do for Monday. Enjoy your weekend.